Okay folks, so now we have reached Climate Science 4, the fourth video in this series, which is titled The CO2 Record is Probably Wrong Too. Now we're starting to see a pattern emerge here that is almost everything we've been told about climate science by everybody, the United Nations, the IPCC, the mainstream media who parrot them, our politicians, most of Twitter, is giving us a story that we're in deep trouble because we have stuffed up the climate due to our emissions of greenhouse gases. Okay, now we're going to look at one of these greenhouse gases that most of the fear mongering is about, that Al Gore's just been here in Australia spouting nonsense about, and that is carbon dioxide. Totally innocent gas, carbon dioxide, which has been demonized for years, for the last 30 years. So here, we just look at a few random internet sites for a start to see what the story is. The current level is over 400 parts per million in the atmosphere. We know that, we can measure it. It's not a problem. Then they compare it, those atmospheric measurements that we're making, they compare it to proxy measurements from the past, from ice cores. This is the ice core record for CO2. From this site, which is Integrate Understanding Climate, the Science of Climate Change. Whoop, there's all the hockey sticks. Here's the temperature and the CO2 record. Just go to another random site, NASA. NASA the facts. Okay, satellite data confirm annual carbon dioxide minimum is above 400 parts per million. For centuries, for hundreds of thousands of years, atmospheric carbon dioxide has never been above this line, never been above 300 parts per million. That's what they say, because of the ice core record, remember. So with this graph, they go back 400,000 years. These are ice cores taken from Antarctica and from Greenland. And then they tag on the end without telling you that these are actually quite different. These are atmospheric measurements taken from Mauna Loa and from Antarctica and from Tasmania. The current level is about 415 parts per million or whatever it is. Have a look at the next one. Another NASA site called Facts, the Vital Signs of the Planet. Be worried. That's what they're telling us. 411 parts per million. Whoo! Danger. Look at that red beeping sign there. That's got to be dangerous. Look how it's going up. Since 2005, 380 parts per million. Now it's 410. We're doomed. Okay, let's see what they say. Carbon dioxide is an important heat-trapping greenhouse gas. Okay. And remember, this is NASA site under facts, which is released through human activities such as deforestation and burning fossil fuels. And here, a bit further down, we have the indirect proxy measurements of CO2, which of course come from ice cores. Note that NASA and the United Nations, IPCC, and the mainstream media and everybody only uses ice core record of CO2. Now note that NASA then shows the years 2002 to 2016 from the CO2 record, and really they've cherry-picked the temperature record. So from 2002, which is a low in the record, to 2016, a massive El Nino high. That's what they do. Totally cherry-picking. Actually, there's been only a 0.2 degrees centigrade rise in temperatures in the 21st century. Cryosphere Sciences. Ice cores for dummies. Oop, hockey stick. Bang. CO2 from DML, South Pole, Low Dome, Sipple Dome. All these ice core records. Look at that ice. Look at that. In the last 1,000 years, CO2's hardly changed, 280 parts per million. All beautiful, all steady. Nothing happened. Then suddenly, evil man came along, started burning coal. Bang, gone off the chart. We're doomed. And just to reinforce that, they got methane. Carbon dioxide and methane and the temperature anomaly together. So, off the chart, there they go. Way higher than for millions of years. Carbon dioxide, greenhouse gas, methane, greenhouse gas, boom, straight off the top of the chart. And the inference is that that temperature graph in the middle, that black one, is going to follow it, and we're all doomed. We're going to be dead in 12 years, according to AOC. Here's another one, British Antarctic Survey. Huh. Top scientific people, same thing. Hockey stick. Huh, bang. 280 parts per million for centuries, millennia, hundreds of thousands of years. Never gone above 300 parts per million. For millions of years. Doomed. They don't mention that this last part is actual measurements in the atmosphere, and the rest isn't. It's just ice core record. Here we are, going back 800,000 years, never been above 300 parts per million. 9 degrees centigrade between the top and bottom of the chart. CO2 goes off the chart and it's up here. What about temperature? That could go up 9 degrees as well. Then what would happen? Huh, our goose would be cooked. This is doomsday scenario. If CO2 is really going like that, and if CO2 drives climate change like they say it does. Here we are, typical site on the internet. You see nice, steady, up and down, interglacials, glacial periods, then suddenly, whoop, man's on the scene, bang. CO2's gone up like a rocket. Temperature's sure to follow. As they claim, CO2 goes up first, and then temperature follows afterwards. Is it true? Is any of this true? Okay, now I think we have to critically look at this last chart in a little more detail. Okay, now for this chart to be a problem for our climate and for us, both of the following must be true. Temperatures must follow the CO2 concentrations. In other words, CO2 must drive global temperatures. CO2 must go up first, and then global temperatures follow, or CO2 go down and global temperatures go down. Temperatures must follow CO2 concentrations. That's number one. And for this chart to be a problem, the ice core record of CO2 must reflect what's in the atmosphere at the time stipulated. So all this red chart, this red line here, for the last 800,000 years, has to accurately reflect what was in the atmosphere at the time. Is that a true record of atmospheric CO2 that's in the ice core record? Has it really never been over 300 parts per million in the atmosphere for the last 800,000 years? And we have one last condition, that most or all of the recent CO2 increase must have been caused by us humans. So for CO2 to be a problem, all three of these statements must be true. Now we know that the last part of the chart, the part that goes from 315 parts per million up to 415 parts per million, we know that is accurate because we've measured that at Mauna Loa. Here's the chart of atmospheric CO2 at Mauna Loa Observatory since 1958 to the present. It's gone from 315 parts per million to 415 parts per million. We can accept that as being accurate. So we'll check them, starting with number one. Temperatures must follow CO2 concentrations. Does CO2 drive global temperatures? Let's check it. Okay, there are a few papers on this. We'll start with Petit et al., published in 1999. It's titled Climate and Atmospheric History of the Past 420,000 Years from the Vostok Ice Core, Antarctica. So what do they say? Well, basically they say that temperatures move first, and then a few hundred years, up to 1,000 years later, CO2 follows. That's on the upside. So temperatures go up, a few hundreds of years later, CO2 follows. Then when temperatures fall, CO2 falls as well, but it takes several thousand years to fall. This brings into question, of course, the idea that temperatures must follow CO2 concentrations. In other words, CO2 should be driving global temperatures. Instead, it appears as though global temperatures drive CO2. So it's an effect and not a cause. Cause and effect have been mixed up here. We look at this graph from another published paper. It shows more clearly the same thing. That is, we've got temperature there in red, which goes up and down first. And then in blue, we've got atmospheric CO2 in parts per million. Again, we got the 170 up to 300 parts per million range. CO2 follows temperature upwards a few hundred years later, and then a few thousand years later, after temperature falls, CO2 follows, as we see here. Now, these conclusions are in the data, in the ice cores. They're indisputable. So the alarmists and the proponents or whatever of the CO2 warming agree that this is what happens. Temperature moves first, CO2 follows, always. It's in the data. But they still manage to weasel their way out of this. They say, oh, wait a minute. Yeah, the temperature moves first, and then it starts CO2 going, and then CO2 takes over. And CO2 actually pushes temperature up afterwards, on the way up. I mean, they're in total denial of the evidence that's right before their eyes. So then we just have to say to them, okay, so what stops the rise in temperature? If CO2 is driving it after it starts rising, what's going to stop it? So if CO2 is driving a temperature up, how does it stop at the top? So, of course, they've got no answer to that. So there goes number one. Okay, number one is gone. So remember that for CO2 to be a problem, all three of these following must be true. One, temperatures must follow CO2 concentrations. In other words, CO2 must drive global temperatures. And obviously, CO2 cannot cause climate change unless it causes global warming first. I mean, that's self-evident. And if CO2 doesn't drive global temperatures, then the whole game is up. The whole house of cards collapses, and CO2 is not a problem. But just to reinforce that, number one is gone. We'll have a look at the Phanerozoic CO2 versus temperature. We'll go back 600 million years this time to show there's absolutely no driving of the temperature with carbon dioxide. Now, we're going right to left here, so the present is on the left at 0, and on the right we've got 600 million years ago. On the vertical axis we've got CO2 in parts per million per volume, and at the present, so there's that orange line there, that's CO2, parts per million per volume. And it has been up at 7,000 parts per million about 500 million years ago, and it's gone up and down, but mostly down. 300 million years ago it was down around where it is now, about 400 parts per million, and then 250 million years ago it went up to around 2,000 parts per million, then down a little, then up again to 2,500 parts per million about 150 million years ago, and it's been a long slow descent from 150 million years ago to the present, and that's where we are now. We've got a very low level of carbon dioxide in the atmosphere right now historically. It's much lower than it's been for the vast majority of the Earth's history. Now compare the CO2 record, which is, as I said, is in the orange there, to the violet colour, which is temperature, the proxy for temperature. Now this is work by Jan Weiser. That's his temperature anomaly over the last 550 million years. You can have a look at his papers to find out how he got that. He uses brachiopods to get that temperature, which is really interesting. And here we have the orange CO2, which is the burner, which is the burner geocarb 3 proxy data, and just those little blue dots you see all over there, that's CO2 from a different proxy, the Roya Stomata from 2008 proxy. We'll come to what Stomata is shortly. Now notice that the CO2 record has absolutely got nothing at all to do with the temperature record. The temperature, as you see, has gone its own way. And about 90 million years ago, it was very high. The temperature was very high, 8 degrees centigrade warmer than it is right now. Then temperatures plunged down and down and down, right down to where we are now. We're in an ice age right now. So to say we're worried about global warming is ludicrous. That's what we need, is a bit of global warming, but it's not going to happen through CO2. So it's clear from this that there's absolutely no relationship between CO2 and temperature on long time scales. And there's no driving, CO2 doesn't drive temperature on any time scale. Okay, so number one is gone. We've shown that in the proxy record, CO2 has never driven global temperatures on any time scale, and it's only an effect and not a cause. So we'll move on to number two. The ice core record of CO2 has to reflect what's in the atmosphere at the time stipulated in the proxy record. So why don't I trust the ice core record? Well, because there's a lot of evidence that it's wrong. We'll look at other proxy records, and these include plant stomata records. Now, a lot of people and governments rely on the IPCC reports, the UN's IPCC, Intergovernmental Panel on Climate Change. And what do they say? In their latest report, the Assessment Report 5, they say that it's unequivocal that the current CO2 level is, quote, it exceeds any level measured for at least 800,000 years. That is the period covered by the ice cores, mainly the Antarctic ice cores, unquote. This is the reference I'll give, CAS 2014. Now we have to remember that a lot of the alarm is based on this. It's based on their claim that CO2 has not gone over 300 parts per million for 800,000 years, and now it's over 400 parts per million. So they say it's our fault, and they say that this is a problem. CO2 drives climate change, which we know it doesn't, or global warming. We've just shown that it doesn't. So we have to look at the ice core record now to find out if it's correct. We'll check it by using other proxy records. Now we know that carbon dioxide is plant food. They love it. The more of it, the better. And plants take in carbon dioxide food through little holes in the surface of leaves that we call stomata. Here's some stomata here, some plant stomata. The number of holes in the leaves and the size of them, so the size and the number of stomata, depends on the amount of carbon dioxide that there is available in the atmosphere. So if there's more carbon dioxide in the atmosphere, plants have less numbers of stomata and smaller ones. If there's a drought of carbon dioxide like there is right now, the plant stomata are more numerous in the leaves and bigger. So this is what we call the proxy of plant stomata, and we can look through the fossil record of plants and find out, count the stomata and find out through that proxy record how much carbon dioxide there was in the atmosphere at the time that those leaves were living. Okay, so what we've got here is a comparison between an ice core record, ice core proxy, which is a Picker Dome C ice core. You can see that here. Now we've got the calendar years before present here, 14,000 years before present, up to 11,500 years before present. So this is just as we were coming out of the last ice age. And we've got the CO2 record here from the ice cores. Look at the scale. The scale goes from 225 parts per million to 255 parts per million, a range of 30 parts per million. Okay. Now we're going to look at another proxy. This work is by Stomata, published in 2013. I'll give the reference. And this non-ice core proxy record for CO2 shows an average of higher than the ice core record, about 250, and a much greater range, as you can see here. This varies, the scale varies from 100 to 450, and the actual measurements vary from about, let's say, 180 to about 425, say. So 180 to 425 in the non-ice core proxy. And in the ice core proxy, you've got a range from, let's say, 235 to 255. So you've got a range of only 20 parts per million in the ice core proxy. So the range is 12 times greater in the non-ice core proxy. That is a massive difference. And not only that, the average is higher. So the average is around 250 parts per million, and the average in the ice core proxy, 240 parts per million. Say 245, if you like. The average is higher, and the range is enormously greater, 12 times greater in range. So the ice core proxies are monotonic. They're steady, steady, steady. They hardly change at all, and they're low. So the non-ice core proxy tells you that CO2 level was actually higher than the ice core proxies tell you, and also had a far greater, enormously greater variability. And of course, Stomata et al. 2013 was not alone in their results. There's three others here, three other plant stomata proxy records I'm citing: Beeling, McEwen, and Rudgren. And they also show, over the same period of time, show huge variability in CO2 concentrations in the atmosphere. So just how accurate is the ice core record of CO2? The most famous ice core, the one with air inclusions allegedly representing the global paleoatmosphere accurately over the last 800,000 years, shows CO2 levels below 200 parts per million for tens of thousands of years, specifically spanning 30,000 to 110,000 years before present. And I'm citing Bonola, 1987, for that. Now, I have also a quote from Saramentino, 1991, who I'm citing here, and I quote, "Most geochemists were convinced that changes such as these could not occur." What he's speaking about here, of course, is the low alleged paleoatmospheric CO2 levels. Such low atmospheric CO2 levels, below 250 parts per million by volume, would have led to the extinction of certain plant species, say McKay et al., 1991, and I cite their paper here. These extinctions have not been recorded by paleobotanists, showing clearly that the ice core CO2 results are not representative of paleoatmospheres. Hence, the CO2 ice core method and its results must be rejected. That is a quote from Jarowski and Segelsad, their paper, which I cite here, published in 1992. So the CO2 ice core record is very suspect, not only in its range because it's so monotonic, but also in showing low levels when there are no low levels, or there couldn't be because plant species would have died out and they didn't. And also they don't show the range that other CO2 proxies show, such as a plant stomata record, for example. Now, just to reinforce the point here that the ice core record for CO2 is almost certainly wrong. I mean, the plant stomata regularly, quite often, shows CO2 as being over 400 parts per million in its record, in its proxy record. For example, we can look at the plant stomata proxy record very recently, which showed that CO2 was over 400 parts per million as recently as 450 AD, so just 1500 years ago. And I cite Cohenberg 2004. And here's his chart. Now, the monotonic CO2 ice record is also shown, but the proxy record zooms up around 450, 500 AD to around 400 parts per million, drops back to about 300 parts per million, and has a wide variability. And at the moment, it's back up to 400 parts per million. Now, is there any supporting evidence for this big bump in CO2 around 450, 500 AD? Well, yes, there is. You look at the central Greenland GISP-2 ice core temperature data, for example, not the CO2 proxy data, but the temperature data from the GISP-2 ice core record. That shows a very large bump in temperatures exactly the same time, at 450 AD. So the Little Ice Age is quite well represented here as well. So we know that this temperature record from GISP-2 in Greenland is pretty good. And we've got further supporting evidence. Good work by Liu from the Tibetan Plateau in China, which shows temperature variations there over the last 2,500 years, and it shows an enormous bump in temperature just after 400 AD. Also clearly shows the medieval warm period and the Little Ice Age and the current warming period, incidentally. And they even predict a fall in temperatures by about 1 degree centigrade between now and 2068. So there's a mystery here. Why does the plant stomata proxy record show a highly variable record for atmospheric CO2 ranging by 250 parts per million, when at the same time the ice core record for the same period shows a monotonic record varying by just 20 parts per million? Now, both cannot possibly be representative of global atmospheric CO2 changes. So now the answer may be related to the Knudsen diffusion effect. And I cite Kowalski et al. Here, 2006, Johnson, 2001, and Jaworski, 1992. Now, this is when a pressure-related diffusion happens in the ice. So above a pressure of 300 bar, this diffusion may significantly affect the CO2 record contained in the ice, effectively minimizing variations by reducing maximums and minimums. So the dissociation pressure for CO2 may even start as low as 5 bar, said Jaworski in 1994. Very important questions are raised here about whether the ice core record for CO2 mirrors the true variability and the true maximums of historical atmospheric CO2 levels. So there goes number 2. Okay, so now we have arrived at stipulation 3. Remember, we don't have to disprove all 3 of these stipulations. If we disprove one, the whole CO2 alarm collapses. But just to drive the nails right home into the coffin of the carbon dioxide alarm, we'll attack stipulation 3, which says that most or all of the recent CO2 increase must have been caused by us. Obviously, if only a tiny portion of the CO2 increase was caused by us, and if the recent CO2 increase was not as big as claimed, then also it's much less of a problem. Now, the so-called pre-industrial is supposedly 280 parts per million. That is, using a start date for industry of 1750, the claim is that the CO2 level in the atmosphere was then 280 parts per million, the so-called pre-industrial level. Now, who set this level? This question goes back to Callendar, the so-called father of the greenhouse effect, who estimated the 19th century level of CO2 to average 292 parts per million by selecting from data compiled by Fonselius, 1956. I'll cite these papers. The selection method was questioned by Slocum in 1955, who stated that without this method, the average 19th century level for CO2 from the data would be 335 parts per million, obviously much higher. So further problems in the matching up of the SIPL ice core records, I'll show that here, and I'll cite Neftel et al. In 1985, with the start of the Mauna Loa measurements of CO2 were pointed out by Jaworowski in 1994, where the unadjusted SIPL data showed 328 parts per million in 1891. It seems that the data was then shifted 83 years forward to match it with the measured atmospheric concentrations from Mauna Loa in 1958. So both Callender's cherry picking of the data and Neftel's matching up of the data, the SIPL ice core data with the Mauna Loa measured data, are both fairly suspect and tend to indicate that they were choosing what they wanted to do with the data rather than just presenting the data as it is. Now, of course, as far as the IPCC is concerned, they've set the pre-industrial level at 280 parts per million, and the current level is 415 parts per million, and they say that all of that increase was caused by anthropogenic emissions, which is 135 parts per million. And they also make the further claim that the temperature has increased from 1750 to the present, 0.8 degrees centigrade globally, and all of that increase is caused by humans, is caused by the increase in greenhouse gases. Now, an important factor in how long CO2 remains in the atmosphere and how much is attributable to humans is the residence time of CO2. How long does it stay up there once you emit it? Now, anthropogenic emissions of CO2 are about 38 gigatons per year, which is 5% of the natural emissions. The natural emissions are about 770 gigatons per year. Now, how long the atmospheric portion will remain up there, it's been a contentious issue in the literature. Chapter 6 of Working Group 1 in the Assessment Report 5 of the IPCC states, the removal of human-emitted CO2 from the atmosphere will take a few 100,000 years. This makes climate change caused by elevated CO2 irreversible on human timescales. And yet there's considerable material in the literature which conclude that the residence time of anthropogenic CO2 is only about 5 years. And I cite Lepori et al., Segel, and so on, Kirk, Hardy. Now, the logic that is used is that the atmosphere currently contains about 800 gigatons of carbon, not carbon dioxide, and about 150 gigatons of carbon goes in and out of it each year. So it's a carbon cycle. Now, this gives a residence time of a typical CO2 molecule as 800 divided by 150, which is 5.3 years. The AR5, in fact, claims that all the rise in atmospheric CO2 since industrialization in 1750 is attributable to man. And yet we know through Henry's law that when the climate warms, CO2 emits from the oceans and from rotting vegetation. So far more comes from rotting vegetation and from the oceans than from us humans. And so how can they say that the climate's warmed and ignore Henry's law that more CO2 must come out of the oceans and from vegetation into the atmosphere? Just doesn't make sense. Only if they believe the ice core record. And this is why we're going back to the ice core record all the time, which is probably as I said, incorrect. Now, all the IPCC's claims in this regard have been disputed in the literature. For example, Hardy argue that just 17 parts per million of the present atmospheric concentration of CO2 is anthropogenic. Lepori say it's 31 parts per million, and I cite them. These figures are far from the mainstream of the IPCC, who say it's 135 parts per million. And I cite Allen et al. 2014 for that. Now, Essing-High argues that there is a short CO2 residence time, and this means that only a small amount of the current global warming can possibly be attributed to man, even if the IPCC's median climate sensitivity is taken to be correct. Now, Lindzen's quite famous for saying that if the temperature's gone up 0.8 degrees and the CO2 has gone up 135 parts per million and the two are related, then that tells him that the climate sensitivity is very low. Now, according to the IPCC's AR5, CO2 is the main climate driver. In fact, an incremental change in atmospheric CO2 causes an incremental change in global temperatures. They're directly related. Then how do they explain this? Which is the CO2 Epicodome sea ice core record and GISP2 Greenland temperature proxy. This is through the Holocene, so the last 11,000 years is depicted here. And you can see there's absolutely no relationship between the CO2 ice core proxy record and the GISP2 Greenland temperature record. In fact, they're completely opposite. The CO2 ice core record, the red one at the bottom, is going upwards, while the temperature record from GISP2 in Greenland is going downwards. So it's been getting cooler for the last 10,000 years right through the Holocene to where we are now. And yet this is just more proof that the CO2 ice core proxy record is totally wrong. It gets more accurate as it gets closer to the present. Now, a lot of you will recognize this. This is man's hockey stick graph, published in 2001 in AR3. Basically, it's tree ring data, bodged up data, and designed to fit the CO2 record. Using tree rings is not a very good proxy for temperature data. This is later work, more reliable work by Ludecky in 2011, shows tree rings versus other proxies. Now, the green are the tree rings, which are fairly flat, and the blue show a more accurate record of proxy record of temperatures, which show the medieval warm period, the Little Ice Age, and the current warming period. Now, here we've got the Hadkrup 4 50-year annual trend. So basically this is just the last 120 years, and it shows the Yoshimura cycle, as I pointed out before, peaking in 1940 and 2000. And of course this is the temperature record, just on a 50-year annual trend. That's all, instead of a yearly trend. This is to bring out the longer-term trends in the measured temperature record. And of course, it bears no relationship to the CO2 record from Mauna Loa. So and before that, it was fairly flat. In the early 20th century was the CO2 record, and in the last half of the 20th century, of course, there's been a steeper increase recorded in CO2. But the rise from 1910 to 1940 and the rise from 1974 to 2000 in temperatures were very similar, and neither were caused by carbon dioxide, because the first one wasn't. Even the IPCC acknowledges that. And the second one wasn't either. Because if the first one wasn't caused by rising CO2, which we know it wasn't, why would the second one be caused by rising CO2? Here's a real correlation, and it's between a temperature proxy, oxygen-18, and solar activity proxy, carbon-14. That is what I call a correlation. There goes number 3. Well, there we are. We only needed one to be wrong, and we've pretty well scotched all 3, I think. That's the end of the CO2 drama.